In the last video, we found the length of line segment A, B. And what I'm going to do in this video is take the thinking from the last video and generalize it. So let's begin. What we know in this case is that the point AB is the point, the point A is the point 1, 2, and the point B is the point 7, 6. And what we can see here then is that if I want to find the point C, I can read it off the graph and I see that it's 7, 2. But observe the pattern here. This 7, that 7, that 2, that 2. So the point C is made up by combining the components of point A and point B. So if we want to generalize this, instead of writing 1, 2, let's give these x, y values. So I'm going to call this x1, y1. And I'm going to call this x2, y2. So we know to find the horizontal length. We subtracted 7 minus 1. But let's do this in a general form. So first thing I need to do is, what is the point C in terms of my other 2 points? And we see that is going to be x2, y1. Pardon me, y1. So now, the horizontal length, AC, can be written as the absolute value of x2 minus x1. And the vertical length which is CB can be written as the absolute value of y2 minus y1. Now in the last video we talked about how the order of these points don't matter because of the absolute value brackets. But a good strategy to put into place is always start with your rightmost point minus your leftmost point, and your highest point minus your lowest point. If you follow that convention, it helps with some other problems later on. So now if I want to find the length of AB. So the length of AB squared is equal to the absolute value of x2 minus x1 squared, that's nice and long, plus the absolute value of y2 minus y1 squared, pardon me. And typically what we'll do now is we're going to do 2 things. Well, first is we're going to take the square root of this side, and since I know any number squared is positive, I just write x2 minus x1 plus y2 minus y1 squared. And since we know that a length is always positive, I don't need to write these absolute value brackets. And this is the formula that we can apply to find the length of any line segment. So this is what you need to memorize. But again, if you understand how to derive it, you won't have to memorize it. So let's go up here and apply it, shall we? Okay, so I've written our formula up here at the top, and we're first going to do line segment AB. So AB is equal to, so A, we've already said is 1, 2. B is 7, 6. So the square root, and I'm going to take 7 minus 1 squared plus 6 minus 2 squared, which is the square root of 6 squared plus 4 squared, which is the square root of 36 plus 16, which is the square root of 52. And if you want, you can get out a calculator and give that approximate value, but be sure to change the equal sign. But in my case, I'm just going to leave it as the square root of 52 because there's no need right now for me to change it. So let's apply it over on this side now. So we're going to find now DE. So D is the point -1, 2. E is the point -7, 6. So remember what I said, that it's really useful if you always take the rightmost point first. So I'm going to say -1 minus -7 squared plus, let me just readjust this a bit, 1 second, that's a little better. So now we're going to take the highest point, which is 6, minus the lowest point, which is 2 squared. So that's going to give me the square root of 6 squared plus 4 squared, and that's equal to the square root of 36 plus 16, which is equal to the square root of 52. So finding the length of a line segment, or sometimes people will say the distance of a line segment, is as simple as using this formula and putting in the correct point values. But again, it's really important, as opposed to memorizing the formula, which I guarantee you you'll do on your own, understand how we derive it, and you'll be able to do all sorts of more challenging problems.